Hi all. I hope you are doing pretty fine. So what are we going to start today? Now we are going to do some question types of alternate work in pipe and cisterns where we would need to keep in mind that we need to be careful about finding the final answer. So this is about the final answer. Right? Now let us move to the question without wasting any time. Okay, now A can do a work in 15 days and B can do the same work in 18 days. In how many days can they complete the work if they work in alternative days in the following manner? So we had done this alternative way or taking them together, right? First we have to make a diagram, right? So let us see, this diagram should be made, right? Okay, now we are putting in some work. Why I'm putting these arrows, you would know in a while. Now 15 and 18 would be the number of days. Now let us use another color. I will use red. Okay, fine. So the total work of 15 and 18 should be 90. That is the LCM of this. How would we find the LCM? 3 into 5 and 3 square into 2 are the numbers. Now there is 3 and the highest power of 3 is 2, right? And 5 and 2 would come as it is and 90 would be the total work. Now to make 1890 we need to multiply it by 5, and to make this we need to multiply it by 6. So in one day we are doing 6 plus 5, 11 units of work, 11 units per day. Okay, now what would we do to find out the total number of days? Okay, in how many days they complete the work? So they are doing this in 2 days. Okay, always take this consideration. Okay, now let us solve the questions with another color. So okay, so what would we do? What would we do now? Fine. Okay, so let us take this further, right? Okay, so we won't use it as 90 upon 11, right? That would give us the wrong answer. So what are we doing here? 11 into, in how many days can we be closest to 90, right? In 8 days we would get 88 units. Now we need to find the first case, right? In this, A was doing the total number of work, right? So we are having 16 days here, right? We have to multiply it by 2, and in 16 days we can do this amount of work. Now in case A, the next day A would be working, so we are left with 2 units. And now we would need to, since A's efficiency is C, we would need to divide it by 3. So 1 upon 3, in 1 upon 3 extra days, right, we would be able to do the work. Now when B would be working, we would put 5 here and we would be able to do it in 2 upon 5 days, right? Now let us move to the next question. So last question was clearly easy. Now let us come to the next question. So this is also easy, but we need to follow a concept of negative work here, right? What is negative work? If a certain person or object, right, does work opposite to the goal, right, then we take the negative work. Okay, so how do we take the negative work? Let us see this example, right? Okay, now what we are doing here, we are just okay making the diagram. So we have 20 and 60 given here. One would go inside and one would go outside. Now this is outside, right? This is clearing, 60 minutes, right? And this is 20 minutes. So this is 20 minutes and this is 60 minutes. Fine. Now this would be 60, right? So into 3 here and into 1 here. So we would have to put negative sign here, right? Because this Okay, this leakage is clearing it by -1. Fine. So what efficiency would we have? The efficiency that we would have would be 3 minus 1 is equals to 2 units per minute. Okay, let us see whether this was days or minute. Yes, this was days, this is minute, right? Okay, now since this is 2 units per minute, what would be the time that would be taken to do the work? It is easy to ascertain right now, right? 60 upon 2, that is 30 days. Not days, minutes. Always remember this, right? Okay, now let us move to the next question. Okay, now this would be a cat level question. Let us see this. Arun switches on 2 taps which can individually fill a tank in 10 and 15 days. So we would have to make the diagram, right? Okay. So this is a fine circle that we have made. Inserting the work 10, 15. Now when we read the sentence, we know that, okay, there was an outlet in the tank. So we would have to make an outlet also. This is the outlet. Fine. Okay. Now he returns at a time when the tank should have been filled. Now when it should have been filled, right, it was filled only 3 upon 4. So now what do we need to find? Okay, in how much time would the tank get filled if he uses only third pipe to fill the remaining tank? So we have to find the efficiency of third pipe, and then, okay, and then we have to find how much time they would take, okay, to fill the tank, to fill the whole tank. Now, okay, the remaining tank. Okay, now, so we have to find how much is the capacity of the tank. So that would be the LCM. So this will be 30. Now we need to find the efficiency, right? So we have an efficiency of 5. So it should have been filled in 6 seconds. Okay. So what would you do? We would just, okay, in 6 minutes, 30 upon 5 would be, so total efficiency was 5 minutes. Now what did we needed to find? We needed to find the efficiency of C, right? So what would you do? Till this time C was also working. So let us see. Minus C, I would add minus C here, right? Okay, so this would be the total efficiency now. Okay, and we had filled, this won't be the correct one, right? We had filled, this was 6 minutes, sorry. So this was 6 minutes. Okay, now we do not need these 6 minutes, right? We have to find the new data. Okay, in 6 minutes, how much, okay, this 6 minutes. In this 6 minutes, how much did we fill the tank? Okay, now 3 upon 4th into 30. Okay, so we would find the value of C. C's value would be, let us see, 5 minus C into 6 into 3 upon 4 into 30, right? Okay, so we can cut it out here. Fine, we can cancel it out here. So this would be 20 minus 4C is equals to 15. Now, okay, 15, 5 upon 4 would be the value of C. Now let us move forward, and the final answer that we are looking for would be, the final answer that we are looking for would be 5, right? Okay, 30 upon, I think so, 30 upon, no, 30, not 30. We need to fill 1 upon 4th of this. Here is where you could have got wrong. This is where you could have got wrong. Now, what do we need to do? Okay, 30. Now, 5 upon 4 would be divided by this. Now, in another 6 minutes, we could have filled the whole tank, right, by using C. So this is the question. Now, when this question could have occurred, right, there are certain times when the author of the question or the setter of the question, the setter of the paper includes data which is not necessary. For example, in this question, Arun switches on two taps which can individually fill 10 and 15 tanks. The same question, but here, in how much more time would the tank get filled if he closes the outlet tank? Okay, so we had 30 units, right? And 1 upon 4th unit was remaining. Now what would it do? We would just divide this by these values, 3 plus 2, right? 3 plus 2. Now 3 plus 2, that is 5. That is all. This is the time that would be taken to fill the tank. If he closes the outlet tank, we do not need to find the efficiency of outlet, right? Efficiency of outlet pipe. It's not be fine, right? So this is easy. So 6 upon 4, that is 2 upon 3 minutes would be taken. Fine. So always know what do we need to find. This statement is always important. Always notice that. So that is all for today's video. I hope you learned a lot, and see you in the next video.